Welcome everyone, and we are going to continue our discussion into trigonometry. And in this video series, we're going to look at some additional formulas. And before we go on though, there have been some kind of properties that we have ignored with trigonometric functions, or at least taken for granted. Some things that we commonly do with real numbers that we're wondering, do they actually work with trigonometric functions? So first, I want to imagine that we're given an angle, theta for all of these, and then with this, is it associative? So associative, you might not remember exactly what that is, but that says that if we have three trig functions in succession, so cosine and then tangent, and then we group them, maybe the first two, for instance, is that the same as if we look at the same three trig functions and just group the last two instead? Well, yeah, I mean, this is addition, so it still works, okay? Are these commutative? So if we do like sine of theta plus cosine of theta, is that the same as cosine plus sine? Well, yeah. Again, real numbers, this is fine. This actually holds with multiplication too for all of these. So we could do multiplication throughout and it'll hold just fine. Okay, distributive. So this would be the idea that if we have cosine of, say, and one angle plus another angle, is that the same as, say, cosine of the first angle plus cosine of the second angle? And this one ends up being not true. Okay, this one fails. At the same time, it's like, we have these things in parentheses. We've always distributed the quantity outside, right? Well, yeah, that works when we had like a number, like if we had a 3 and then x plus y, we could distribute the 3 because it was a real number and get 3x plus 3y. But the problem is that we have a function out in front, okay? So it doesn't work that way, okay? And just to verify that, we can look at the next example. So we know sine of pi over 2, go to the unit circle, that's 1. And then we have this quantity. We can represent it as, pi over 4 plus pi over 4, or really that's, 45 degrees plus 45 degrees, okay? So that's true. So sine of, pi over 2, yep, that's true. If we look at adding these two, sine of pi over 4 is square root of 2, and add that square root of 2. And so if I add those, I get 2 square root of 2 over 2, which is just square root of 2, which is actually bigger than 1. Okay, so this is a quick example to show you that sine of pi over 4 plus pi over 4 in parentheses is not equal to sine of pi over 4 plus sine of pi over 4. Okay, and so that might be a little uncomfortable for us, but it's just a fact of life that we're going to have to get used to. And we're wondering, like, what can we actually do? If we have, a sum of angles, right? Is there another way that I can work with that? Because I'm not always going to be given pi over 4 plus pi over 4, or, nice angle plus nice angle, okay? And that's where the angle addition and difference formulas come in to play, okay? So you will want to get these down. They are on our class formula sheet. In particular, I'm going to say make sure to get the first two rows down. Those are actually pretty useful. The tangent formulas, yeah, they're a thing, and make sure to jot them down. We don't use them that often. But the things that I want to highlight in here is that U and V are representing angles, so you could use alpha and theta, whatever. But I want you to notice the pattern. Okay, with sine, right, we have addition between the angles inside, and then on the opposite side, we have addition as well. When we have subtraction, we have subtraction between them. Okay, and similarly or I guess cosine is actually the reverse. Addition leads to a difference, and a difference leads to addition. Okay, so just keep track of your signs. It's going to be super important to keep those straight. okay? Tangent is a little similar, but a little wonky. So you have addition, and then you have addition on top, subtraction down below, and vice versa if you switch the signs, okay? So just pay attention to all those, okay? But just running through the formulas, what they say is that if you have sine of u plus v, it's sine of the first times cosine of the second angle, and then cosine of the first, sine of the second, okay? And it's addition, so you can reverse them, okay? Cosine, I remember it as, for cosine, you have cosine, cosine, sine, sine, okay? So that's kind of how I remember it. And then with the sine formula, I just remember it's sine and then sine 1, cosine 2, cosine 1, sine 2, okay? Maybe that's helpful for you, maybe not, okay? Now, how do we actually use these, okay? They help us find values of kind of odd angles that we might not know immediately from the unit circle. So for example, sine of 75, right? 75 is not one of our nice angles from the unit circle. However, with a little bit of thinking, and this part takes a little bit of time, you could say, okay, well, 75, that is, 30 degrees plus 45 degrees. And those happen to be nice angles on the unit circle. So then via angle addition, I can say, okay, well, and I cannot, okay, again, do not say that this is sine of 30 plus sine of 45. You will get it wrong and you will make me cry. Don't do that. Okay, but what you can say is that according to the angle addition formula, this would be sine of 30 degrees times cosine of 45 degrees, okay? So effectively from the above formula, 30 is u, 45 is v, and then plus, because I had a plus in there, cosine 30 times sine 45, okay? And if I number crunch this through, I might need to use my unit circle. Sine of 30 is 1/2. Cosine is square root of 2 over 2. Cosine of 30 degrees is square root of 3 over 2. And then sine of 45 is square root of 2 over 2. Simplifying, you get square root of 2 over 4 plus square root of 6. You can multiply underneath the square roots over 4. So we just commonly write this as square root of 6. Square root of 2 plus square root of 6 all over 4. All right. You can do the same thing with the expansion. So now for this next exercise, I have to take a minute and look at this thing. Okay, so there's a lot of things going on. I don't know any of the angles. I could punch these in a calculator and get an approximate answer, but this says exact, right? So I need to get a nice expression for this. So that has no decimals. So if I take a minute and look at this thing, right? Cosine, cosine, sine, sine, that happens to follow the pattern of the cosine angle addition. And in fact, it's just the expanded side. So what this should be equal to is cosine of 99 degrees, and then there will be 36 degrees, and I want to put a minus in here, but I have to check the sign. Minus means add inside, okay? And if I do that, I get cosine of 135 degrees. Oh, that's a nice angle from the unit circle. Quadrant 2, cosine is negative, and ends up being square root of 2 over 2, okay? So with these identities, you can go either way. You can, use it to collapse a big expression like we just did, or you can use it to expand a compact expression by recognizing that as a sum of angles.